here. Okay, so I'll continue with this divergence we have finished. I'll continue with curl of a vector field. So here and there, as I said, I was making a typing mistake. For example, there's a spelling mistake here. So curvilinear. Here also there's a spelling mistake. This should have been I. So these are just minor mistake. It hardly matters. Okay. So curl of a vector field. I think everybody knows that like already in Cartesian system. Wait. In Cartesian system, your a vector is a1 I cap plus a2 j cap plus a3 k cap. Here I cap, j cap, and k cap are the unit vectors. A1, A2, and A3 are coefficients of I cap, j cap, and k cap, and they are actually the components of the vector A. Okay, components of the vector A: I cap, j cap, k cap. Suppose you have random vector A here, you can have the components of the vector A on this component is called your A1, and the component of the vector A on your j cap axis or y axis is your A2, and the component of this vector A on your z axis is called A3, right? So likewise, in curvilinear coordinate system also, you can write your vector field. When we talk about vector field, there's a vector constant vector as well as vector field. Constant vector means if all these components A1, A2, and A3 are constant. But if this component A1 is a function of x, y, z, the coordinate variables, if A2 is a function of your coordinate variables x, y, z, and if A3 is a function of your coordinate variables x, y, z, then that means this vector is a space dependent. That A1 as a function of x, y, z means this component A1, it changes from one, the value of this component changes from one location to another location in coordinates. Like suppose I have one point here, x1, y1, z1, for example. Suppose these are the coordinates value, and here let's say you have your coordinates value x2, y2, z2. So depending on all these coordinate variables, if these quantities are not fixed, if these quantities are variable, then you have a vector field which is varying in space. You have a vector field which is varying in space. Okay, so such kind of vectors are called vector field. And suppose I have a vector like this, which is 2I cap, for example. So this is, let's say this is a vector. This is not a vector field, okay? Or this is a constant vector. This vector is a constant vector, okay? So as you see, any point you take, this is your I cap direction, and this is your j cap direction, this is k cap direction, for example. Any point you take over here also, your vector will point along your I direction. It will have a magnitude of 2. Out here also, your vector will point along the I direction. It will have a magnitude of 2. Any point in the space, anywhere you go in the space, it has the same magnitude 2, and also pointing along the same direction. These are constant vector field. Okay. So here, when we talk about this vector field, just consider that you have a A1, A2, A3, which are a function of coordinate variables. So just like the one we discussed here in the Cartesian system, in this orthogonal system also, you can write a vector field A as A1 E1 cap. In place of your I cap, you have now tangential in vector E1 cap, E2 cap, and E3 cap. And A1, A2, and A3 are functions of, what will be A1 function of? A1 will be a function of u1, u2, u3, the coordinate variables. A2 is also a function of u1, u2, u3. A3 is also a function of u1, u2, u3. Just like that, right? So the coordinate variables in this general orthogonal curvilinear coordinate system, we denote it as u1, u2, u3. So in place of x, y, z, you have u1, u2, u3. In place of I cap, j cap, and k cap, you have tangential unit vectors along the coordinate lines e1 cap, e2 cap, e3 cap. That was what was already discussed in the previous lecture also. Right. So when you are going to take a curl of a vector field, you have to have a del operator operating on the vector field. Curl means when there is a cross product between this del operator and the vector field. When there is a dot product between a del operator and a vector field, this is called divergence. So I forgot to upload your results, cat1 results. Tomorrow when I visit the college, I can upload the cat1 results also. Most of you have been like your performance were very poor, so I totally understand that like it's quite difficult to study in online mode, but uh, this is the only means of teaching or education that is available to us, so you have to give your effort, really effort. You have to really try hard to learn out of this online lecture, online mode of teaching. So I suggest everyone to, as I often said, I suggest everyone to write down everything. Okay, so that your performance will improve in your C2 CAT2. Now, yeah, without practice or without writing every step, so I found that many of you are randomly scribbling something here and there out of your vague memory of what you see from your phone screen, or maybe. So learning should not be like that. So if in order to learn all these mathematical steps, you have to write it down yourself. If you simply read it from your phone screen, you will not be able to write down anything in the exam. So I suggest everyone to mute yourself. So like the usual divergence we discussed, when you take curl, you have a del operator cross product with your vector field. So individually, this del operator will operate on all the components of this vector field. And here, this is what we already discussed. Gradient of u1. I think in the previous class, we have already discussed this. Yeah, we have already discussed this. Gradient of u1, as you see, if you revise my lecture or my notes, gradient of u1 is e1 k upon h1. This we have already discussed about this. So we will use the same identity that when you take a gradient on the surface, u1 equal to c1 surface, gradient on u2 equal to c2 surface, gradient on u3 equal to c3 surface. This is what we get. And from here, you can, using this identity, you can write curl of a1 e1 cap, as in place of u1 you write h1 gradient of u1. So these are just some simple mathematical steps. Now here again, a1 is a scalar. As you see, a1 is a certain scalar function, a2 is also a certain scalar function. Just like that, in curvilinear system, a1 is a scalar function of u1 u2 u3. So a1 and h1, they are two scalar quantities. H1, what was h1? H1 is the scale factors. If you remember, this was del r upon del u1 magnitude. So magnitude means h1 is also a scalar. So a1 into h1 is, you can consider it as a certain scalar function phi. And gradient of u1 is a vector quantity. You can take it as a vector b. So if you do that, curl of gradient of curl of a product of scalar n. This vector is this is a vector identity which you can easily prove. I suggest you prove this yourself also. Oh, sorry, there is a this thing. No need to do this. So this is a cross product. The vector sign should be on top of b vector only. So this will be gradient of scalar cross product with b plus scalar into curl of b. So following that, if you follow this vector identity, this quantity will be, this quantity can be written as gradient of a1 h1 is in place of phi, you write a1 h1, in place of b you write gradient of u1. So this is what you will get. Now we also know that curl of a gradient of any scalar function is 0. You can prove this yourself also. Curl of a gradient of any scalar function is 0. So this quantity will be 0 again. Now, if we consider that here gradient of u1 is e1 upon h1, so you will arrive at this relation e1 upon h1. And this is gradient of a scalar quantity. And we already know that the del operator in curvilinear coordinate system is e1 cap upon h1 del upon del u1 plus e2 cap upon h2 del upon del u2 plus e3 cap upon h3 del upon del u3. So if you use this del operator in curvilinear coordinate system, orthogonal curvilinear coordinate system, this is what you will get, right? So you just have to substitute just have to put a1 h1 here, because del operator operating on a1 h1. Now e1 cross e1 cap. So e1 is a tangential unit vector. If you take a cross product with that vector itself, it will always be 0. Why is that should always be 0? Because this will be magnitude of this, magnitude of this. These are unit vectors, and sine of the angle between them. What is the angle between them? Sine of the angle between them is 0. And cap sine 0 is 0. So e1 cross e1 is 0, and e2 cross e1. So we talk about this orthogonal curvilinear system. So we consider that we are considering only orthogonal curvilinear system. So in orthogonal curvilinear system, e1 cross e2 will be e3. Just like in the case of Cartesian, I cross j cap is k cap. But if you consider e2 cross e1, e2 cross e1 cap, this will be minus of e3 cap. This will be minus of e3 cap. Okay, so yeah, I have already written here. So this is what the vector identity, the orthogonal unit vectors, in orthogonal system, the unit vectors are related like this, just like in the I cross j and j cross I. So e2 cross e1 is minus of e3, and e3 cross e1 is the plus of e2. So you have these two terms. This is your curl of a1 e1 cap. And similar to that, you can calculate your curl of a2 into e2 cap. You can also calculate your curl of a3 into e3 cap. So just like we obtained this expression, please follow the steps. Please follow the steps over here. By following the steps over here, please obtain the expression for curl of a2 e2 cap, curl of a3 e3 cap yourself. So if you derive all the steps yourself, you will have confidence in these mathematical steps. So it's not assignment. I'm not going to give marks out of it, but for your own sake, for your own purpose of learning, please derive this to yourself, just like you obtained this. We obtained this here. Okay, so if you do that, you just combine them, and this is what we get. Okay, if you want to confirm it, you can do the determinant of this yourself. h1 h2 h3. The first term will be h1 e1 cap into del of A3H3 upon del of U2 minus del upon del U3 A2H2 plus H2E2 will be the second term. Just like that, you can calculate yourself. And H3E3. Yeah, please mute. Okay, so this was the usual, like similar to what we already know. Please work out the remaining steps. Now, this is where I want to spend a little bit time on for today's session. So this is a cylindrical coordinate system. Cylindrical coordinate system is curvilinear system. Curvilinear. Why do we say that cylindrical system is a curvilinear system? In cylindrical system, in place of your x, y, z Cartesian system, you are using rho, phi, and z. So these are the coordinate variables of cylindrical system. That means here in this case, your u1 is rho, your u2 is second coordinate variable is phi, third coordinate variable is z. Third coordinate variable is z in this cylindrical coordinate system. Okay, so let us see. So what is rho? In a cylindrical coordinate system, rho is the distance of the surface of this cylinder, the distance of this surface of the cylinder from the z-axis. See, this is the z-axis, and rho is a distance of this to this. So rho is the distance of the surface of the cylinder from the z-axis. So like if you consider a small cylinder, your rho will be this. Your rho will be this. Okay. And your phi coordinates is the angle subtended with respect to this x-axis is your phi coordinates. And your z coordinate is the distance along the z-axis, or the height along the z-axis is called your z coordinate, right? So now looking at this particular system here, if you look at this point here, you consider a point P here. Let me circle it, let me make it a little bit bigger. You consider this point P. The location of this point P, you can define it using your cylindrical coordinate system. Okay, let me write it here. So I think I don't want to make a mess out of the drawing. So let's say this is your x, y, z coordinate system, Cartesian system, and let's say we have a point P. We can define the location of this point P. If I drop a perpendicular here, and I can find the x coordinate value and the y coordinate value, and similarly the z coordinate value. I can define the location of the point P with x, y, z coordinate variables. I can locate the point, right? But in certain physical problem, or in certain algebra, or any other mathematical problem or engineering problem also, it might not be it might be quite cumbersome to solve your physical problem using your XYZ Cartesian system. So in certain cases, like if your engineering problem or your physics problem is having a certain kind of cylindrical geometry, if it has a cylindrical geometry, if you represent your point location, or if you use your rho, what is that, rho phi z coordinate system, it can simplify your mathematical steps. So how do we represent this point rho here, this point P using this rho phi z? To represent this point P using this rho phi z, first thing is I need to know rho. I need to know the distance of this point P from the z-axis, that is called rho, right? And I also need to know the height of this point from the xy plane. The height of this point P from the xy plane is your z value. So you need to know rho and z. And also you need to know, in order to clearly identify the location of this point, you need to know the angle subtended with x-axis here. If you know rho, phi, and z, then the location of the point can also be identified. The location of the point is known to us. So in place of xyz system, I can define my geometry, I can define my coordinate system using this rho, phi, z, called the cylindrical coordinate system, and I can solve my physical or engineering problem if my engineering problem has a cylindrical symmetry or a cylindrical structure. Okay, so uh, now say in order to in order to implement a coordinate system, using that coordinate system, I should be able to locate or identify any points in the space. I should be able to locate or identify any points in the space. So in your XYZ Cartesian system, in order to locate any point in the space, what is the very x range? X value can go from minus infinity to plus infinity, isn't it? So in order to represent some point behind this, x value can go up to minus infinity, x value can go up to plus infinity on the front side. And also, if you look at your y coordinate system, y value can go from minus infinity to plus infinity. So if you vary your value from minus infinity to plus infinity, you can represent any point along the y-axis. And similarly, if you vary your z variable from minus infinity to plus infinity, you can represent any point along the z-axis. So if I consider this coordinate axis like this, extending from minus infinity to plus infinity, in all the cases, I can cover the whole space. Now, in order to cover the whole space, what will be the limit of or the range of rho here? The range of rho is simply the distance of the point. Rho is simply the distance of the point from the z-axis, right? Rho is simply the distance of the point from the z-axis. So there is no concept of minus value. There is no concept of negative value here. Say you are simply measuring the distance of the point, any point in a coordinate system from the z-axis. So on the z-axis, the value is 0. But if you move away from that, the distance is rho. So if you want to cover the whole space, you can vary rho from 0 to infinity. Like suppose you want to represent any point here. So let's say this is a point Q. What you have to do in this coordinate system is that first you measure the distance of this point from your z-axis. So let's say this is your rho prime, let's say. And you have to measure your the distance, you have to measure the height of this point from the xy plane, that is, let's say, z prime. And you have to measure how much angle is subtended here. How much angle is subtended here? You have to measure this whole angle phi prime. So like that, you see that in order to cover any point in the space, rho can go from 0 to plus infinity. 0 to plus infinity. There is no concept of negative value here in the rho here. It simply starts from rho equal to 0 to infinity. It simply starts from the distance. It simply measures the distance of any point you consider in the space from the z-axis. So on the z-axis, the rho's value is 0. As you move away from the z-axis, rho value is increasing along the positive direction, and it can extend up to infinity in order to cover all the points in a space. And also, I think by now you should see that in order to cover all the points in a space, z coordinate should also vary from minus infinity to plus infinity. Because if you consider z value from 0 to infinity only, then you will not be able to locate those points which are below this xy plane, which are below this xy planes, you will not be able to locate any points along that. So you have to extend z value from minus infinity to plus infinity. But if you have a point here, let's say point R, point rho coordinate is simply the distance from the z-axis. So this is, let's say, rho double prime. So you simply have to measure the distance from the z-axis. So there's no concept of negative value for the negative quantity for rho here. Rho will go from 0 to plus infinity in order to cover all the space. Now, the next question is, what will be the range of our phi coordinate? So I have already written here anyway, so I was not so the phi coordinate, in order to cover every point on the space, you should be able to rotate around 360-degree. So if phi equal to 0, phi equal to 0 means you can locate any points on this. You can locate any points on this xz plane. On xz plane, phi is 0. However, on your yz plane, if you consider yz plane, phi value is 90-degree here. And in between, you can vary from phi equal to 0 to 90-degree. You can cover any points in the first quadrant here. You can cover any points in the first quadrant if you vary phi from 0 to 90. Now, if you vary phi from 90 to 180, 90 to 180, it will cover this second quadrant. So you can, by varying phi from 90 to 180, you can cover all the points within the second quadrant here. Now, if you go from 180 to 270 here along this, if you move your phi value between this, that is 180 to 270, then this will cover all the points on your third quadrant, and 270 to this 360 will cover the points on your fourth quadrant. So by varying phi from 0 to 2 pi, and also by varying rho from 0 to infinity and z from minus infinity to plus infinity, using this rho phi z coordinate system called the cylindrical coordinate system, you can cover any point in the space. Now, what will be the coordinate lines look like? Here in your Cartesian system, you know that coordinate lines, x coordinate line is a straight line, y coordinate line is a straight line, z coordinate line is also a straight line. Here you see that your rho coordinate line will vary from 0 to infinity. That means rho coordinate line is a straight line. Rho coordinate line is a straight line, as you can see, right? And what about your phi coordinate line? Say, if you fix the value of rho here, if you fix the value of rho and vary phi from 0 to 2 pi here, if you fix the value of rho and vary phi from 0 to 2 pi, when you start with phi equal to 0, this is phi equal to 0 point, and as you increase phi value, but if you fix the rho value, it will move along the circle. So your coordinate line corresponding to phi is a circle. Coordinate line corresponding to phi is a circle, right? Coordinate line corresponding to phi is a circle. Coordinate line corresponding to rho is a straight line. And coordinate line corresponding to z coordinate variable. Z coordinate variable is also extending from minus infinity to plus infinity. So this is also a straight line. So therefore, here in this cylindrical coordinate system, you have three coordinate variables, rho, phi, and z. Out of these three coordinate variables, phi coordinate is a curve. Phi coordinate is a curve. Okay, phi coordinate is a curve. So this cylindrical coordinate system as a whole, you can classify it as a curvilinear coordinate system. All right, curvilinear coordinate system. Now, what are the transformation relations with the Cartesian system? I think from here you can see that from this figure itself, you can see that x is rho cos phi, y will be this would be your y here. This is your phi. Y will be rho sine phi. Y will be rho sine phi. Z is simply z, and you can have a reverse transformation. There you can see that this is your y, this is your x, rho is your hypotenuse of this right angle triangle. This is 90 degree, so rho will be equal to square root of x square plus y square, and tan phi is y upon x, so phi will be tan inverse of y upon x, and z is simply z. So z coordinate variable is common coordinate variable in the case of cylindrical and Cartesian system. Now, yeah, what are the coordinate surfaces now? Rho equal to c1. So if you fix rho equal to c1, if you fix rho equal to c1 like this, for example, if you fix rho equal to c1, that is rho value is fixed. Rho value is fixed if once you fix rho value, and if you keep the remaining variables like phi and z to be variable, you will have a cylinder like this. You will have a cylinder like this. Okay, you will have a cylinder. So this infinite cylinder extending from minus infinity to plus infinity. Rho equal to c1. Just consider rho equal to c1. If you consider rho equal to c1, and if you consider z to be variable from minus infinity to plus infinity, let's say you extend from z value from minus infinity to plus infinity, and your phi value to be varying from 0 to 2 pi, your phi value to be varying from 0 to 2 pi, by fixing rho equal to c1, by varying from 0 to 2 pi, you are tracing out a circle. If you fix the value of rho and if you vary phi from 0 to 2 pi, you are tracing out the circle. Then if you vary z from minus infinity to plus infinity, then you will have large number of or infinite numbers of circle, and that will form an infinite cylinder. So an infinite cylindrical surface. So this surface, as you see, it is a cylindrical or curved surface. This is a cylinder. This is a cylindrical surface. A cylindrical surface is a curved surface. Okay. So as I already explained at the beginning of this curvilinear coordinate system, in a curvilinear coordinate system, at least one of the coordinate surface is also a curved surface. Just fix the value of rho, you will get a curved cylinder out of that. And if you fix the value of, let's say, if you fix the value of your phi, if you fix the value of your phi here, you will see that you will have, by varying rho from 0 to infinity, by varying rho from 0 to infinity, and also by varying z value from minus infinity to plus infinity, by varying z value from minus infinity